problem 4 here, you have this shown out in your notes, but you want to take a second to model this in a calculator to make sure that you really understand what you're doing. So we see here my P of X, my population of Corpus Christi between 1970 and 2005. This function models that, but notice that it's a cube root function or a radical function that has a third root. So when we go to put that in our calculator, whether we use Desmos or the graphing calculator, I'm going to show you on Desmos first. So I've already got my 75,000 typed in here, but I want cube root, and notice down here there's only square root. So I'm going to come over here into my functions menu, go to miscellaneous, it normally starts on trig, go to miscellaneous, and there you'll find our cube root. So we type that, and then x minus 1,950 goes under the radical. And when I hit enter, that's going to graph it. But notice, in order to see that, we need our graph huge, and it's very hard to see the appropriate model of this scale because look at what's happening to my x-axis. So this range is really hard on Desmos to model, so this is one where we would better model it in a TI-83. So if I pull up my TI-83 and type in the same function, pay attention to what we're trying to solve here. What we're trying to do is say, in what year was the population of Corpus Christi 250,000? So we talked about this in class just the other day, but if we type in one function, 75,000, and now for cube root on a TI, we actually just want to do my any root. So if I go into my math menu, I can always find these options. So there's cube root right here. Or I can do any root, and I can determine that. But since we want cube root, I can go ahead and use that. Cube root of x minus 1,950. And what's nice about your TI is I can go ahead and easily model another line. I'm just going to make a second line for at 250,000. And then when I graph it, it's not going to be on my graph. This is a 10 by 10. I can try to use my zoom fit and see if that works. So again, go to your zoom menu, go down to the last option of fit, and it kind of maybe works, but again, one line is way up high, one line is way low. So I'm actually going to manually set my window. Thinking about what the y values are, actually thinking about the x values to begin with, my x is going to be my years. If I look at this where x is the years, so if I'm going from 70 to 2005, that's 35 years. I'm really just going to go ahead and make that range 40. So I'm going to make my x start at 0, my x max be 40, make my x range be 4. Now I have not tried this yet. I'm just kind of modeling it free form just at the moment. We know that our population, there's no way our population will drop below 0. So I'm just going to go ahead and model that as 0. My y max is going to need to be over 250,000 to be able to see that. So let's just go ahead and make it 300,000 to make things easy. And then my y scale, it's always good to be a tenth of your range. So my range there is 300,000. So my y scale, I'm going to make 30,000. Let's see if that graph is any better. So there's my population line, but it seems to be having an issue modeling the curve. So if I check if I've done everything right, 75,000 cube root x minus 1,950. So if we actually want to take this back and look at a parent function to begin with, what is just the cube root function? Well, if I get rid of this, make my y equals, and I just do cube root of x and graph that, I have to zoom way back in to actually see what's going on. You slowly start to see, there we go. The cube root function is really cool because I can take the cube root of the negative. My domain is not restricted by only positive x values. So my cube root kind of makes this kind of like an S-curve. Be careful calling it an S-curve, but that's kind of what it looks like. So we see I do get higher and higher, but it's going to happen very, very slowly. So let's just, as we try to figure out, well, what happens to this parent function when I change things? What if I take away 50, or let's make it smaller, if I subtract 5, it shifts it over to the right-hand side. So we know that that subtraction is going to move it right. So if we try this again in our calculator, if I get this to turn back on. I know that's going to shift right, 1,950. So actually that bumps me over a lot of years. So this is compensating for my X value actually being able to be the year that it is. So we actually need to go back and change this window. I'm going to start it in 1970 since that's where our range started. And I'll just end it in 2015 so we go a little beyond that. Oh, of course I put those in the wrong place. So 1,970 for the year 1970. My max, let's just make it this year, 2016. We'll make this scale, I don't know, we have a range of about 40 years there, so let's just make the scale 5 to make things easy. And now if we go to graph it, we can actually see the curve and we can see our straight population line. So to find that point, we want to go second, calculate, go to the intersect tool. Again, you're going to start on one of your lines. So we try the intersection point right there. We do the second curve and then we do my guess point. Again, I can drop all those in the same location. What you should see is that your X value is 1987 and your Y value should be exactly on that 250,000 that we plotted. So in the year 1987, which hopefully matches what Pearson had, in the year 1987 is what we found out is when the population would equal that. And we see 1987. So what we did is correct. So again, be careful with the window. You always got to make sure that you can actually see the function that you want. And sometimes it takes a little bit of playing around. So go ahead and try this again with the got it. You might be able to keep the same window since we're close. Since it says between the years 1970 and 2005 again, but notice that we're subtracting away a different value, so be careful. I'm actually going to stop this video and I'm going to finish this problem at the beginning of part 5. So go ahead, let the video stop and try this on your own. Type it into your calculator, make sure you get the values on your own because on our mastery assessment you're going to have to be able to do this. I again would not use Desmos, I would use your graphing calculator.